Okay, so thank you all for being able to present here today. This paper is Migration and Crop Change, Evidence from Brazil using a spatial equilibrium model. This is actually an initial working paper, which is coming from my master thesis, which was advised by Professor Paula Pereda and co-advised by Jaqueline Oliveira. And we will probably work on this topic for some time into the future. So the main goal of this work is to model and assess internal migration and crop change as adaptation mechanisms to climate change. And in our model, the workers will choose a location to live and a sector to work, given the locational amenities and labor market conditions. So this is the migration part of our model. And the farmers will choose which crops will be produced at each given location, given farm gate prices and crop suitability to the local agroclimatic conditions, which is the crop choice part of our model. So to motivate the exercise that we will do here, here we have the predicted change in summer and winter average temperatures in Brazil, comparing the baseline climate to our mid-century climate predictions under a high emission scenario. And as you can see, here in Brazil, there are some micro regions that are expected to have smaller increases in temperature, some regions that are expected to even have decreases in temperature, and some regions like the Brazilian Midwest, where temperatures are expected to increase by a lot. Okay, so in terms of climatic amenities, this kind of shock will likely produce migration as a result. And in terms of agriculture productivity, we will look at crop choice because different crops are expected to be impacted differently by climate change. So here, for example, we have coffee and wheat, expected attainable yields, the expected change in crop attainable yields, comparing the baseline climate to a mid-century climate scenario. So in terms of wheat, in all the Brazilian territory, wheat is predicted to lose productivity, but the productivity is expected to decrease the most in the south and southeast of Brazil, which is the exact opposite of the coffee production in our country. So in the south and the southeast regions of Brazil, there are some places where the productivity of coffee is actually expected to rise, according to data from GAES. Okay, so some of the literature that our work relates is on climate change and migration, where we have some empirical works on how weather impact migration. Here we have Marcury, Maystad, and Schumacher, and Cattaneo and Petty, but there are actually a lot of papers on this topic. There are some papers on how changes in climatic amenities are expected to change locational choices. And here we have Timmins and Sinhacalques proper, but these ones are more interested in estimating the willingness to pay for the climatic amenities. And there is also work by Kai on the partial effect of temperature and effect on and the effect of temperature on agriculture productivity, on migration. And the paper that we relate the most is Oliveira and Pereda, which uses a spatial equilibrium model where temperature and agriculture productivity impact migration. And our contribution to the literature in terms of this paper is to add the crop choice adaptation mechanism to climate change. And in terms of crop choice, our work relates to CUI, which estimates the effect of climate change on crop substitution in the US. And we also relate to works on crop switching simulation, and this work by Cochineau and co-authors, which use land suitability data to observe how crop change can work as a mechanism to mitigate the effects of climate change. In our model, we will have workers in agriculture and agriculture sector, and we'll try to maximize their utilities by choosing the location and sector pairs. And the indirect utility brought on by location and sector will depend on the wages offered by that location and the sector, the housing rent cost in that location, and on climatic, non-climatic, and sector of employment amenities. Migration will be costly in our model, and inside our migration costs, we'll have a fixed utility cost from migrating from a region to any other, and a cost that will increase with distance between the two locations. And the probability that a worker will migrate from place J to location K to work in sector S will follow this format here, which derives from the Fouché distribution of workers' utility.
Just to understand, the shock is at the location level, not at the worker level. So it's a utility is defined at the KST, right? Just to...
the idiosyncratic utility shock is at the worker level.
At the worker level. So
here.
Worker
level.
Okay.
Okay. So actually, the utility of workers depend on this indirect utility, on the migration costs, and on the idiosyncratic shock, taste shock. Okay.
Okay.
So for the model on the agriculture farm, the agriculture farms will be able to produce up to n distinct goods, which we call crops, and the technology for producing each crop will be Cobb-Douglas type with labor and land as inputs, and constant returns to scale, and a total factor productivity here, which is a function of the land suitability of that crop. Okay, so this total factor productivity here is the channel by which climate change impacts each crop productivity and agriculture productivity as a whole. The cropland shares will depend on the revenue expected for each crop in our model. So the cropland shares depend on the local price of that crop and on the expected crop yield for that crop in that region. And the wage in the agriculture sector for each location will depend on the land-labor ratio, on the expected crop revenues, and on the distribution of of the cropland shares. Okay. We will also have a non-agricultural sector, which is not impacted by climate change. And the production in the agriculture sector is a function only of labor. And the wage in the agriculture sector will only be a function of labor supply. And we also have a housing market here, where the housing rent cost will depend on the land rents in that location. And the land rents will be a function of the marginal productivity of land in agriculture. And the housing rent cost will also be a function of the demand for housing in that location from workers in both sectors. So how exactly climate change will impact our economy here? Well, first, climate change will have a direct impact on climatic amenities and crop productivities. So climate change will impact this climate amenity here and crop productivities here. So after that, farmers will respond by reallocating their inputs according to the new optimal set of crops for the new climatic conditions. Because as you can see here, when this total factor productivity here changes, the optimal set of crops also changes according to this equation of cropland shares. So after that, changes in agriculture demand for labor and land will impact in agriculture wages and housing rental prices. Workers will evaluate their prospective indirect utilities based on the new climatic amenities, wages, and housing prices. And then they'll choose their new location sector pairs, considering the migration costs. As workers migrate, wages and rents will adjust by local supply and demand, which further alter their locational choices, and a new equilibrium will be reached when no one has incentives to migrate anymore. Okay, so now to estimate our parameters and then simulate what will happen to our economy, we'll use this data. We will have the senior population census to get information on the hourly wage rate in both sectors, the sector of employment of workers, the housing rent costs, and the municipality of residence in the census years and 5 years before the census years. And with this information on the municipality of residence is how we get the migration flows across time. We'll use the 2006 agriculture census to get information on farm gate prices, on crop yields and crop production area. We use data from GIS for the agroclimatic attainable yields under the baseline climate and under our future climate change predictions for the mid-century. We use data from INPE for historical daily weather data for summer and winter average temperatures, and accumulated rain, and accumulated sunshine hours. And we use information from INPE for future climate forecasts on average summer and winter temperatures under our climate change scenarios. So to obtain our parameters, first we calibrate the labor share cost in the agriculture sector and the share of workers' income spent on housing. After that, we estimate our land share elasticity parameter using the cropland share equation. We estimate our migration costs and the indirect utilities using the migration probability equation. And we estimate the remaining parameters using information from the equations on our indirect utilities, the non-agriculture firm equation, and the housing market equation. So first, for land share elasticity, this is the only one that we need to estimate with a cross-section data using only the 2006 agriculture census. Because local price and local cropland shares are endogenous to each other, we need to instrument the local crop price. And for that, we use an interaction between this exposure to foreign trade index and log distance to the closest major agriculture product export. And the estimate of our parameter theta that we have here is 1.11, which is a quite low elasticity, which means that the cropland shares respond slowly to changes in prices and in crop productivities. We also have here our estimates for the migration costs in our economy. As we can see here, we have a quite large fixed utility cost from getting out of your origin microregion, and we have increasing costs with distance from a microregion to another. Okay, and for our remaining parameters, we estimate them using log first differences forms of our equations, and we also use instrumental variables in all these cases. So we use a measure of labor market access, we use Bartik shocks, we use an indicative variable for having a large labor market prior to your period of analysis, and an agricultural revenue shift share for the land rent here. And the parameters that we get from that are first and wage elasticity parameter, which shows that workers are attracted by increases in wages. Increases in summer temperatures are disamenity to workers. So people do not like when summers get hotter, but workers enjoy higher temperatures during the winter. For the non-agricultural wage equation, we see that an increase in labor supply decreases wages in the non-agricultural sector. And in the housing market equation, we see that increases in the land rent costs and increases in the housing demand, they both have positive effects on housing rent costs. Now that we have estimated our parameters, we can simulate what will happen to our economy. First, we try to see what will happen to the allocation of crops in the Brazilian territory. And in terms of changes in cropland shares, comparing the baseline climate to a high emission climate, looking for maize production area and coffee production area, we see that for maize, the land share allocated for that product is expected to decrease in the southeast and south regions of Brazil, but increase in the north, Midwest, and most of the northeast regions. And in terms of coffee, we expect an increase in production area in the southeast and the south of Brazil. However, I must warn that for goodness of fit, for cropland shares is still bad at this moment, and it's something that we are trying to try to make it better in next version of this paper. But these are the results that we have now. In terms of migration rate and agriculture employment shares in Brazil, what we see is that climate change is expected to increase migration rates across micro regions under both low emissions and high emission scenarios. And the agricultural employment share is expected to decrease. The crop change adaptation mechanism is not expected to have much of an impact on the migration rate, but we find some effect on the agricultural employment shares. And if you paid some attention here, we can see that the difference between when we have crop change and when we don't have crop change at each climate change scenario is bigger than the difference between the two scenarios here. So the impact of being able to introduce crop change in our economy is relatively important. And in terms of regional effects that we can observe, we can see that the northeast region of Brazil is the one to be impacted the most by climate change in terms of migration rates. So out migration from the northeast region of Brazil will be very large under climate change scenarios. But when we compare the case where the climate stands as the baseline climate, and when the climate changes, when we look at the southeast region of Brazil, we see that outmigration is reduced when we have climate change. In terms of the agriculture employment share in our economy, the northeast region and the north region of Brazil are the ones that will be most negatively impacted by climate change. But the south region is the one where agriculture employment is expected to rise when we have a change in climate. However, this increase in the agriculture employment share in the region only occurs when we introduce crop change, okay? So at the low emission scenarios, the sign flips here. And in the high emission scenario, without crop change, there isn't much of an impact on the agriculture employment share and without crop change. But when we have crop change, the agriculture employment share grows, okay? So in conclusion, what we see here is that our results suggest a spatial redistribution of crop productions under future climate conditions, helping mitigate some of the effects of climate change on agriculture share of employment. the agricultural adaptation will likely have minimal effects on aggregate migration rates. And there are regional differences on the effects of climate to be expected, with the Northeast macroregion being predicted to have the more significant increases in outmigration rates and decrease in agriculture share of employment, while the South macroregion of Brazil is where crop change is likely to impact the agriculture share of employment the most.
Quick question. Do you have any intuition why in the previous slide, the North and Midwest regions, like they increased the migration rate, but they decreased the agricultural productivity? So it's like people are migrating from the Northeast to the, wait, no, I'm confused here. So when you have a positive migration rate, it's like people going out of that region.
Going out of that region.
Ah, okay, okay.
Okay, so people are going out of that region, but here we are not seeing to what regions they are going to. Okay. Okay. Okay, so any more questions here? No.
I have a second question. So in the motivation slides, you show the productivity of like wheat and coffee, and then like, but then you have like maize and coffee in the results, right? So what is the productivity of maize going on here? Like, what would be this graph here on the right hand side with maize? Yeah.
Well, right now I can't remember exactly, but the productivity of maize is decreasing in all the Brazilian territory. So probably it's the production area of wheat is decreasing.
And do you have any reasons to choose like these crops? Like I don't understand anything about agriculture, but in my mind, like soy is probably like the most representative one. Or
okay, we have information on 18 crops in our study. But I chose to show you maps on coffee and wheat here, and coffee and maize at the results slide, because they are the maps where we have like complements, like where one is decreasing is where the other one is increasing. But actually, right now, how we are estimating our model, some crops are like under predicted, and soybean is one of those crops which is being heavily under predicted in our model, which is something that we need to adjust. Okay. So thank you for the questions, Roberto.
Okay, so if you do not have any further questions, I think you can go on to Roberto's presentation.
Okay. So can you see the slides changing? Yes, right? So thanks everyone for coming. It's a pleasure to present here at SBE. I'm going to present racial gaps in the labor market, the role of non-white entrepreneurship. This is joint work with Marina, who's in the meeting right now. And I'm Roberto Rocha. I'm a 4th-year PhD student now at UC Berkeley. So our motivation here, we think that in many economic settings, the identity of people is important for the outcome of the interaction. So what I mean by that, for example, in jury decision, it's been shown that like if you have black jury, the black defendants might have like a higher possibility of not being guilty, or if you have female professors, female students tend to do better in their classes. And there's some evidence that this might be relevant for labor markets as well. So for example, this paper by Laura Giuliano that shows that if you take one store in the US, the manager's race might be important for the outcome of the new hires, Or for example, this new paper by Biasi and Satsens that shows that the gender of who you bargain wages with appears to matter for the outcomes of workers. But I would say that often in labor market analysis, firms are assumed what I'm calling here identityless agents when studying labor market outcomes. Okay, so we're not thinking about who is running the firm usually. But by reckoning with the fact that firms are owned and operated by individuals, it seems natural to us to ask whether the identity of entrepreneurs or firm owners affect the outcomes of their workers. So this might be particularly relevant when we think about the racial composition of entrepreneurs. And why that? Why is that? In the US, for example, Black individuals are severely underrepresented in entrepreneurship. And on average, their firms perform much worse than firms owned by individuals with other races, from other races. And in Brazil, that's similarly true. So if we take PNAD, we see that a white individual is almost twice more likely to become an entrepreneur than a non-white one. And non-white individuals also have smaller earnings when they are in entrepreneurship than white ones. So, but although there are large bodies of literature studying both the racial gap in entrepreneurship and the racial gap in the labor market, the relationship between both is much less clear. So there is not much studies going on into what is the relationship between these two forces in the economy. And this paper will provide this link between the racial composition of entrepreneurs and differences in labor market outcomes between white and non-white workers. We're going to study this in Brazil, in the Brazilian labor market context, where these groups that we're grouping as non-whites, that consist of pretos, pardos, and indigenous, represent more than 50% of the workforce, but less than 30% of formal entrepreneurs. So we restrict our focus here to entrepreneurs that hire at least one formal worker, and we're going to, so just like a quick comment, we're going to use firm owners and entrepreneurs interchangeably, okay? What we do is we create this novel data set that links information, including race of firm owners, to the universe of formal employment in Brazil. And this allows us to investigate how labor market outcomes of employees vary according to the racial composition of the entrepreneurs or firm owners from the firms they're working at. So just a quick preview of our findings, we find that controlling for a wide set of covariates, the share of non-white workers in firms with non-white entrepreneurs is 18.7% higher than on the average firm. We also find that the adjusted racial wage gap is 32% smaller in firms with non-white owners. And this increases to actually more than 40% if we restrict our sample to workers with some college. And we show that this is in part driven by non-white workers accessing better occupations or managerial occupations or jobs that are higher up in the hierarchy within a firm if they are in firms with non-white entrepreneurs relative to if they were in firms with white entrepreneurs. And in the last set of results, we have this set of results that we're calling transitions to entrepreneurship, where we also show that non-white workers that are working in firms with non-white owners are 15% more likely themselves to transition from employment to entrepreneurship than non-white workers in firms with white owners. Okay, I think this relates to several strands of the literature. I'm just going to highlight that I think the biggest contribution of this paper is to creating this data set where we can observe both kind of like this ownership meshed employer-employee data set where we can observe the race of the firm owners. And this is probably unique to our knowledge is unique and kind of like a new finding if we think about racial gaps in both entrepreneurship and labor markets and making this connection. Okay, so I'm gonna try to go, I have a lot of results. I'm gonna try to go fast through the context since this is mostly a Brazilian audience, but I think it's safe to say that Brazil is a country marked by racial division. So it was the last country to abolish slavery in America and the country that received the most forced African migration. So if we take PNAD in 2015, the official record said that pretos, pardos, and indigenous account for like 54% of the labor force, and amarelos and brancos, which we're grouping together, but our results don't depend on that, account for the other 46%. Okay, so using PNAD, we're going to show some descriptive statistics here. So first, this is a graph about the racial wage gap through time. So although we see that the unadjusted wage gap, which is the yellow line here, it decreases significantly between 1996 and 2015, we see that the adjusted wage gap, where we are controlling for state fixed effects, gender, and age, it's relatively stable, okay? And furthermore, if we decompose the adjusted wage gap, which is here is basically constraining for gender and state fixed effects, among 3 different education groups, we see that workers with some college are have a much higher racial wage gap here. And the racial wage gap here is basically like a mean serial regression, taking the data from a dummy that has non-white. So here, even in 2015, after all this decrease in the unadjusted racial wage gap, a non-white worker still has like, with some college, still earns around like 35% less than a white worker. Okay. And with PNAGI, we can also characterize entrepreneurship differentials. Okay, so if we simply run a linear probability model on the likelihood of you being an entrepreneur, okay, if we don't control for anything, we can compare the constant and the coefficient here, and it suggests that a non-white individual is like almost more than twice less likely to be an entrepreneur than a white one. Controlling for observable characteristics, this coefficient remains super large, super statistically significant, and negative, showing that this is not necessarily explained by observable characteristics, which are the same ones as education, gender, and statistics effects. And the same thing with earnings. Non-white entrepreneurs earn much less. So here I pulled data from 2011 to 2015 to get some power, but it's on average like 15% less, even controlling for observable characteristics. Okay, so this is just kind of like a descriptive situation of the current racial disparities in both entrepreneurship and labor market outcomes in Brazil. Okay, so let me just check the time here. Gotta run a little bit through the data here. So we use 3 administrative records to construct what we are calling this comprehensive data set of firm ownership in Brazil. We basically use the CNPJ, which is this new data set by the Receita Federal, which is public, and it has firm information from a subset of owners. And we complement this by collecting data from juntas comerciais. And with that, we get like ownership information for more than 90% of for-profit establishments in Brazil. I'm gonna show some descriptive stats later. But these 2 data sets don't have the race of the owner, so we have to match them to HICE to get the race of the owner. So what we have is we have the race of owners who appear in HICE at least once between 2003 and 2010. Okay. So just as a reference, if we take the cross-section of workers employed in the for-profit private sector in Brazil in December 31st of 2017, this is kind of like our summary statistics here. So we have like around 96% for 96%, we have the owner's name, but only for 68% we have the owner's race, because we lose a bit of, we have some attrition in this matching between the ownership data and HICE to get the race. But we still have the race information of around 70% of workers. And since we have race information for 70% of workers, I think it's expected that the sample is very similar to all sample in HICE. So if we compare columns 4 and 1 here, we have a pretty balanced sample. They earn a little bit more, like around 6% more. But if you think about like racial composition is very similar, average age, gender, education is much similar as well. Okay. So I'm just going. If you have any questions, please stop me. So let's start with our 3 main results. Now I'm gonna start with sorting, then I'm gonna go through racial wage gap, and then I'm gonna end up with transitions to entrepreneurship. So we start our sorting analysis at the firm level. So we're just basically running like an OLS model here, where we're correlating the share of workers that have share of non-white workers in a firm J with a dummy owner J non-white, where owner J non-white is a dummy that takes value 1 if the firm has at least 1 non-white owner. We're going to use this definition for non-white and ownership of a firm throughout our analysis, but in the paper you can check that we have several robustness checks that account for other definitions here. But it's useful for us to have like this reduced to 1 dimension. I'm going to talk about, so the controls, I'm going to use all the controls that are observable in HICE, such as municipality and sector fixed effects, share of workers and owners with high school and with college, share of women workers and owners, average age of workers and owners. And we're going to estimate this using the 2017 cross-section and include only workers between 25 and 60-year-olds that have a full-time non-temporary contract. So I think this table here shows the coefficients beta, gamma 1 for a different set of controls. So let me take like 1 minute here to show some results. So I think the columns 1 is the one that is not controlling for anything. So here it already motivates that there is a large difference between firms with non-white owners and firms with only white owners in the share of non-white workers at the firm. But this is a lot driven by municipality geographic regions, okay? So I didn't put the map today in the presentation, but the map of non-white workers and firms with non-white owners overlaps a lot. But even if we control for municipality fixed effects, the coefficient remains large and statistically significant. I'm sorry, didn't put stars in the tables today. But, and interestingly, if we compare columns 2 and 3, where in column 2, I only put municipality fixed effects, and column 3, I exclude municipality fixed effects and include all other firm controls and worker controls, such as education, sector, gender, and age of both owners and workers, we see that the coefficient doesn't change much from the specification where we don't include municipality fixed effects. And if we compare columns 2 and 4, where we have both municipality fixed effects and all other controls, we see that the coefficient is very similar to column 2. So what this tells us is that once we control for geography, every kind of control that we add is not mattering much, and the coefficient for non-white owner remains pretty stable. The difference between columns 1 through 4 and columns 5 and 6 is that in columns 5 and 6, I weight that by the number of workers, and the coefficient, once we control for all the controls here, doesn't change much as well. Okay, so from column 4, which is our preferred specification here, we would say that firms with non-white owners have 18.7% more, a higher share of non-white workers than the average firm in our sample. So doing certain things at the firm level, I think it's the most intuitive way to think about it, but we can also do workers level sorting. So when we use worker level data, it allows us to flexibly control for worker characteristics and to explore better what is driving the results in heterogeneities. Okay, so we estimate kind of like the reverse model in this specification, where we have a data set that is identified at the individual level. Okay, and we are observing if they have an owner that is non-white or not. Okay, so we're interested in the coefficient beta 1 here, which is telling us the likelihood that the difference between the likelihood of a non-white worker and a white worker of working for a firm with non-white owner. Okay, so this is first a motivation just to say that even if we control flexibly for all these worker characteristics, we still have like a positive and significant sorting between non-white workers working at firms with non-white owners. And it's the same pattern here, where we control for, once we control for municipalities, the coefficient doesn't change much, and adding controls such as education, sector, firm, and owner characteristics doesn't change much of results. Okay, so once we control for municipalities, the sorting is still present and large. And the nice thing about worker level specification is that we can investigate many possible heterogeneities. Okay, so how we are going to do this today, we're going to estimate the model on a subsample, conditioning on a given subgroup. So what we find is that we find no particular difference in workers' characteristics, such as gender and education, but we are going to find large differences in the sorting by firm size and workers' tenure at the firm. Okay, so here is the plot of the coefficient beta 1. If we divide the sample by men, women, the 3 education groups that we use, less than high school, and more than high school. So there is not much difference in sorting here. But here is a nice result on firm size, okay? So if we divide the sample by firm size, we actually find that the sorting is much larger in smaller firms. And I think this is intuitive because we would expect that owners and entrepreneurs have more say in the day-to-day decisions, such as hiring and firing, in firms with smaller firms, okay? And lastly, we have this result on the workers' tenure. And we see that for workers that are staying up to 4 or more years in the firm, this sorting effect is almost twice as large as workers that are in their first year of the firm. In the paper, I'm not going to show you this today, but in the paper, we used longitudinal data to show that the job spells of non-white workers survive more in firms with non-white owners. And this is kind of driving this tenure pattern that we see here. Okay, so let me jump now to the racial wage gap in firm with non-white owners. Okay, so what we're going to do is we're going to focus on this specification here where we have the interaction between the worker's race and the owner's race. And I'm going to take a little bit of time explaining this because we're going to be using this all throughout the rest of the presentation. So here again, we're using the 2017 cross-section, and I have individuals I wage, and a dummy of a worker being non-white, a dummy that indicates if the worker I work at firm J who has a non-white owner, and the interaction between non-white worker and firm J with a non-white owner. Okay, so we can think about here that beta 1 will give us the adjusted racial wage gap, adjusted because I have the set of control XIT. Okay, the beta 1 will give us the adjusted racial wage gap in firms without non-white owners, in firms with white owners, and the sum of beta 1, beta 2, and beta 3 will give us the adjusted racial wage gap in firms with non-white owners. And nicely here, we can also include firm level fixed effects, and we're going to do this in our preferred specifications. And whenever we include firms fixed effects, we're going to ask the beta 2 will be omitted because it will be perfectly correlated with the firm fixed effects, and the difference between the adjusted racial wage gap in firms with white owners and non-white owners will be due to beta 3. Okay, and beta 3 is this variable here is not perfectly correlated because it's the interaction between both. So here I have the video in front of the table here. So here we have our main results here for the racial wage gap. So what this table is telling us, first column 1, without any controls, anything, is telling us that non-white workers on average have around 30% less log monthly wage than white workers. Once we control for municipality fixed effects, age, gender, and firm level characteristics, this reduces significantly. Once we also control for education, this decreases even more, and this is similar to those patterns that I described to you using PNAGE dataset. And then when we go from columns 4 to 6, we have kind of our main results with the interaction here. So columns 4 doesn't include firm level fixed effects, but we see here that the positive coefficient on the interaction is telling us that the racial wage gap is smaller in firms with non-white owners. And if we sum this up, we see that non-white workers actually receive more in firms with non-white owners than in firms with white owners. And once we add fixed effects, so column 5 is adding firm level fixed effects, but without any of the other controls. And column 6 is our preferred specification where we can think about the adjusted racial wage gap in firms with white and in firms with non-white owners. We see this difference here, this positive coefficient here, which indicates that racial wage gap is 32% smaller in firms with non-white owners. So we can put this up in a graph, and we find that the adjusted racial wage gap in firms with white owners would be something around 0.86, like kind of 9%, and this would be 6% in firms with non-white owners. Okay, so although it doesn't decrease everything, it doesn't kill the racial wage gap, but it decreases it substantially. Okay, so now I'm going to present a series of heterogeneities that are obtained by doing like a multiple interaction model here. So if we see things by education, as I've shown you in the PNAGE section, in the context section, we see that racial wage gap is increasing in education. And we also find here that the interaction effect is increasing in education. So this is more substantial for educated workers. Now, if we look at the racial wage gap by the tenure of the worker at the firm, here we see an interesting pattern where this interaction effect is much larger for workers that are longer in the firm than for workers that are at the beginning of their tenure at the firm. So this kind of positives a question of like, what is driving this? Is this something that is driven by wage growth, like differential wage growth of non-white workers at firms with white and non-white owners, or just simply like selection of better wages? We have some results that show that this is like 35% selection and 65% wage growth. And several other robustness checks here, where we can put individual fixed effects, different racial compositions of workers, and check if like what happens to the wage variance in these firms. But I'm gonna go for the results that I think are more interesting here. So what is driving this difference here? So we posited that our wage results are driven by non-white workers accessing better occupations or higher ranked jobs in firms with non-white owners. Okay, so what we do is we run the same interaction specification that we have, but with different measures on the left-hand side here. So first we run something like an occupation rank, where we use the CBO, the Classificação Brasileira de Ocupação, to rank occupations and see what happens to their interaction. And we also run a specification here that I think I'm gonna spend a little bit more time here, where we have like an indicator function. So like simply a dummy, if the workers is in the top 10% of workers within that firm, and we can play around with this top 10% and show that it's kind of like monotonically increasing if we think about the rank of the worker in that firm. And I'm gonna show these results here. If you have any questions, please interrupt me. So if we just think about occupation rank and top 10 best percentile, here we see positive and largely statistically significant results on both like the rank of the occupation that you are. So you're at better occupations if you are a non-white worker working at a non-white owner firm. And the same thing on your likelihood of being in the top 10 best paid within a firm. Okay. This is much more significant for workers with some college or some workers with more than high school, which is kind of like this story that we're thinking about, where this are the group that are more severely affected by racial disparities, racial inequalities in Brazil. And so we also, I didn't bring it today here, but we also do some specifications where you use the manager's Classificação Brasileira de Ocupação, and we find similar results here. And if we take this top 10% best paid within a firm and use that dummy, but to using all the ranks here, we instead of top 10%, so this is the coefficient that we found here for top 10%, but if we use that for all the ranks within a firm, we actually get this like nice monotonic situation where non-white workers are less likely to be in the bottom of the firm if they are in firms with non-white owners, and more likely to be at the top of the firm. And this is particularly relevant for workers with more than high school or some college, where this is steeper here, and you can see this kind of pink coefficient here. Okay. And lastly, we can also run, so let me see time, I have 7 minutes. So we can also run the racial wage gap specifications that we've shown you today, but controlling the sample for controlling the equation, adding occupation fixed effects and rank within the firm dummies. And we see that once we add that, of course, they absorb a lot of the variation, but once we add them, basically the racial wage gap decreases substantially. Both if we think about like the interaction effect, sorry, decreases substantially, both if we think using all workers, but also if we think about the interaction between workers and workers' education. Okay, so in the last set of results, I'm gonna focus on like, can this also be creating like a feedback loop between this lack of non-white owners and the lack of opportunity for non-white workers? So we investigate if working for a firm with non-white owners changes the likelihood of the worker becoming an entrepreneur. We define becoming an entrepreneur as occurring when the individual starts a firm that has at least one employee or becomes a partner on an existing firm with one or more employees. We take out of the sample here those workers that are becoming a partner in the firm that they were originally working at, because I think that those are kind of like different dynamics here. And so here we're pulling data from 2008 to 2016, and we are thinking like, okay, this guy is working here at period I, this guy I is working at year T, and we see if they become an owner at year T plus 1. And first we see similar results here where this table has stars, I had to adjust it, but we see similar results here where non-white workers are much less likely to transition to entrepreneurship. But if we focus here on columns 6 and 7, they are if they are working for a firm with non-white entrepreneurs, they are more likely to do so. Okay. And this is true also in the sense that it's much more likely for workers with education. Okay, so the coefficient is much higher for workers that are having more than high school. Okay, and once we control for occupation fixed effects and the log wages, these results decrease significantly. So if we compare 1, 2, and 3, columns 1, 2, and 3, 1 is the baseline specification, 2 is once we control for log wages, and 3 is once we control for occupation fixed effects. Okay, and this suggests that the interaction effect kind of like becomes 0 once we control for those characteristics. And this is interesting because it's telling us that workers accessing better occupations in firms with non-white owners also kind of like push them to entrepreneurship and creates them kind of like this positive, let's say, feedback loop. For workers with more than high school, even when we control for wages and occupation fixed effect, the coefficient is still there, which kind of suggests some kind of role model. I don't know, I can't explain this by anything in the data, but there are many possible stories here for what's happening in column 6. Okay, so to do a short recap of our main results, I think here is wrong, it's 32, but this paper shows that non-white entrepreneurs are relevant to the labor market outcomes of non-white workers. So what we showed is that firms with non-white owners employ 18.7% more non-white workers. The racial wage gap adjusted for observable is 32% smaller in firms with non-white owners. Sorry for the typo here. And adjusting for observable covariates, non-white workers are 15% more likely to transition to entrepreneurship if they were working for non-white owners rather than if they were working for non-white white firm owners. And I think our personal interpretation as a kind of like a more subjective discussion about the topic is that I think these results can be seen like through 2 major different angles. Okay, so in a more pessimistic view, we kind of our findings suggest the prevalent underrepresentation of non-white entrepreneurs hinders the economic opportunities for non-white workers and also diminishes the chances that a non-white individual goes from employment to entrepreneurship, kind of generating this kind of negative vicious cycle in racial disparities. But we also can have like a more optimistic view because it kind of suggests this, although I don't have any evidence on it, but you could think about these results as suggesting that policies geared towards the reduction of the entrepreneurship racial gaps might not only be relevant to the entrepreneurs themselves, but also have these externalities, if you might, effects in the racial gap in the labor market outcomes. Okay, and that's all I had for today. Any questions? I'm happy to. I just went.
Roberto, you said that you didn't count the situations where workers became partners of the companies that the firms they were. But have you run those regressions?
Yeah, it's similar. I think it actually inflates the coefficients. Yeah.
Oh, okay. Okay.
Yeah.
But do you have any interpretation for that?
So, interpretation in which sense? I'm like.
Because you said that these were different dynamics.
I see. Yeah, that's a good point. So what it happens is that, so it's kind of like, let me share the screen here quickly. So if I do that, what happens is that it's kind of like the percentage change, it doesn't change much. Okay, so the relationship between this coefficient, which would be beta 3, and the coefficient beta 1, it's kind of like similar. What it happens is that the dependent variable here is like a rare event, and this becomes like a more common event. But so since I'm thinking about like creating new opportunities or like non-white workers accessing this, like, because I think the idea on this exercise is like, can this like create new opportunities themselves? I'm thinking like if the guy becomes a partner in the firm that are working at, it's kind of like not necessarily creating that, but it's a good point.
Okay, good. Okay, I got it. Thank you, Roberto.
All right, 6:30, right on time. Yeah.
Yeah. So does anybody have any further questions? Otherwise, I'll start sharing my screen here. Okay. Okay, so I think everyone can see. Let me start my clock also. Okay, so good morning, everyone. Thanks, Gabriel and Roberto, for the excellent presentations. So I'll start presenting my work on commodity booms and structural transformation. And similar to Gabriel, this also comes from my master thesis at the EESP. And in this sense, it's still kind of preliminary also, the results that I'll show you to you today. So, so as the main motivation, like the big question that I want to answer in this paper is how commodity booms affect structural transformation. And in particular, I'll take a more in-depth look on the relationship between the expansion of the agricultural sector and structural transformation in open economies. This is particularly interesting when because when we go to the theoretical and empirical literatures about the subject, we see that this relationship between the expansion of the agricultural sector and structural transformation is still kind of ambiguous, both in the theoretical and empirical. Oh, and just a detail, always when I'm saying the expansion of the agricultural sector, but in this kind of literature, I always think about an increase in the productivity of the agricultural sector in comparison with manufacturing and the service sector. So, for example, both the paper, the seminal paper of Matsuyama, the theoretical paper, and a recent, with still preliminary results, but a recent paper by Feisbaum and Johnson, more empirical, shows that depending on the degree of trade openness, this relationship between the expansion of the agricultural sector and structural transformation can go both ways. So, for example, if we take a closed economy in an autarky, when there is this shock to the agricultural productivity, there is a structural transformation effect goes on in the sense that labor is draw away from agriculture into the other sectors of the economy, in special manufacturing. But on the other hand, if it's an open, small open economy with an initial, at the start of the period, and an initial comparative advantage in the agricultural sector, the opposite goes on, and labor is drawing into agriculture from the other sectors, and structural transformation in this sense is slowed down. So in this sense, the empirical, we still have like some empirical evidence which this effect is ambiguous and depends heavily on this kind of mechanism. And overall, this question also relates to the labor pool versus push effects, which is more prevalent in generating structural change. If it's labor being pulled by other sectors of the economy away from agriculture, or is it agriculture by itself that is pushing labor away from the sector? And so the other main question of the paper that I want to answer is how other factors, other mechanisms might be explaining also these effects in open economies. In special, I'll take a look on underlying characteristics of the agricultural sector related to agricultural modernization and inequality that might again explain or mediate this relationship between the expansion of the agricultural sector and structural transformation. So just a summary, in this paper, I used the 2000s commodity price shock as a source of endogenous price variation, and I focus on the Brazilian municipalities as a setting. I do this for a couple of reasons. Mostly, most of them are very common or very familiar to us, but we know for a fact that Brazil was greatly affected by the last commodity super cycle, and it's also a country that shows that has high levels of agricultural modernization and then inequality. In the empirical part, I construct a shift share measure to estimate the effects of the price shocks on the local reallocation of factors across sectors. The main factors that I'll take a look, it's mainly labor, but also capital and land in the farms, and the three major sectors being agriculture and manufacturing in the service sectors. And then my main finding is that municipalities that have benefited more from the shock experienced a reallocation of labor away from agriculture and into the manufacturing sector in specific. I do not find any effect on the service sector. And then I go on to explore some potential mechanisms related to agricultural modernization and inequality in land holdings. And what I found in terms of mechanisms is that those same places, those same municipalities also show an increase in the use of capital inputs. And as capital inputs, I'm using some measures of use of modern machinery, so tractors, planters, and harvesters inside the farms, and also the share of land being being planted with genetically engineered seeds. And also, and this as a particular mechanism could be, I interpret this as being used as capital being used as substitution for labor. And also the same places also show an increase in land inequality, which I interpret as being related to the displacement of small rural owners or small farmers away from agriculture and into the other sectors of the economy. And then just a quick background. Again, most of this information here is familiar to most of us, but the last commodity super cycle started around 2000 and peaked in 2011. So here at the right, I plot the aggregated commodity price index for the agricultural sector. So you see that very fast in terms of the time frame, and also very high in magnitude. And in this sense, it's comparable to the other two super cycles that we have observed historically, the ones that followed the Second World War and the Second Industrial Revolution. And in terms of the Brazilian economy, we know for a fact that is the one Brazil is one of the largest producers of agricultural commodities, but most important than that, it has a great regional variance in the degrees of agricultural specialization. And this is particularly interesting for me because this I will take leverage on this too in my empirical exercise. Okay, so for the data sources, I use 3 major data sources to construct my exposure measure. The first one being PAM and PPM from BGE, which I obtain the production of crops and cattle for each year in municipality in metric tons. Then I go out to the World Bank's pink sheet to get the international commodity prices, and then I aggregate these at yearly values. And then, again, similar to Gabriel, I use the FAO GAIS crop potential yields in tons per hectare to obtain what normally economists use and interpret as exogenous measures of agricultural productivity in each location for each crop. The basic idea here is that FAO GAIS calculates this using geoclimatic features of each location, such as soil quality, rainfall, climate, slope, and so on, and then aggregate this into a model that gives these crop potential yields or productivity measures that only depend on these exogenous features that depend only on geoclimatic variables. For the outcome part, I use the 3 last rounds of the population and agricultural censuses, again from BGE, and I obtain employment shares and wages in the major sectors, land and machine use. I also obtain number in the area of farms to calculate land Gini, and also get some baseline controls. And from impaired data, I get auxiliary variables such as sectoral GDP and additional socioeconomical and geoclimatic variables. Okay, so the first part of the empirical strategy is to calculate what I call the predicted agricultural shares. In this sense, I follow closely what Fassbein does in a recent paper of his and use a fractional multinomial logit to calculate these predicted shares. The idea here is to first use as dependent variable what I call the average local crop endowment share in each municipality, which is basically defined as the total. What I do to calculate this is first that I take the total agricultural production in the 5 years, the average total crop production in the 5 years preceding the start of the shock, so between 1995 and 1999, and I take this total agricultural production and I see how much each crop contributes, so the share of contribution of each crop to this total agricultural production in each municipality average over these 5 years, and then I regress this variable into the vector of the FAO GAIS crop specific potential yields. And then what I'm interested here is on the predicted values of this variable, which has this closed form right here that I'm showing you. The intuitive idea of using these predicted values is that it's reasonable to assume that these average local crop endowments have both an endogenous component and an exogenous component, the endogenous one being related to crop plantation decisions based on socioeconomical characteristics, path dependence, historical crop productions, and so on, and also can be made by exogenous component, which itself depends on, again, geoclimatic features, similar to what FAO GAIS use in their model. So the idea here is to filter out the endogenous component and use only the variation that is due to the exogenous component related to the FAO GAIS values and variation. So I get this predicted agricultural shares, and I argue that they are sufficiently exogenous to this regional variation in crop production. And just another quick comment, this model can also be motivated by a simple optimal crop choice model that based on later work by McFadden, in which you can assume that farmers are profit maximizers and they are price takers, and they are choosing their optimal crop allocation of their land, given that they know the vector of potential productivity of the land, or in this case, they know the FAO gaze vector of potential productivity of the land, that again depends on the geoclimatic features of the land. So in this sense, in a model that we assume these features, it's reasonable to assume that these predictive agricultural shares also are kind of reflecting these optimal crop allocations of the farmers in this kind of scenario. Okay, so to construct the final measure, I simply interact these predicted agricultural shares with the log of the international commodity prices, and then I sum over all the commodities to obtain the final commodity exposure measure here, which varies at the cross-section of the municipalities and at the time period T. And just a quick comment about this measure, it's basically multiplying prices by quantities, but in a more fancier way. And this, in this sense, is very similar to what other works, mainly in the Dutch disease literature, have been doing. But I think most of these works, they try to instrumentalize in some ways these price by quantities measures. And in this sense, my kind of marginal contribution to this is to try to provide a measure that does not depend on the instrument or any other kind of variable to instrumentalize for this, as I'm assuming basically that we have the municipalities as small open economy, so the international prices, they cannot, they are not big enough to sufficiently interfere with the international prices, and so this assumably to be exogenous, and also the predicted shares are also assumed to be exogenous given the empirical strategy of the logit that I just showed you. So the idea is to construct a measure that does not depend on any instrument and so on. Okay, so for the main equation, I simply use as outcome of interest y over municipality I and year t, and I regress this into the exposure measure, and also add a vector of baseline controls for the prep period, so for the 1991 census, and I also add the usual municipality and year fixed facts. Since for both the agricultural census and the demographic census, I will only have two time periods of observation, so for 2000, 2010 for the demographic census, and 2006 and 2017 for the agricultural census, t equals 2 here. So this main equation here basically collapses into a first difference form in which the fixed effects are absorbed. So I'll be mainly estimating this equation right here in first differences. And the idea to add the prep period controls is that I want to control for heterogeneous initial characteristics or initial paths of development across the municipalities. So I add population density, income per capita, illiteracy rate, the share of rural population, and regional fixed effects for the 5 main regions of the Brazil territory. Okay, so for the main results, here are more the results related to the population census outcomes. So, and just a quick comment, in every table I'll present 4 columns in which I sequentially expand the set of controls that I just commented. But anyways, and because of time constraints, I only focus on the column number 4, which is also my preferred specification, which adds all my proposed controls. So when you first look at the difference between, again, 2000 2010 in deployment share in agriculture related to the increase in the exposure to the commodity boom, we see that these more exposed localities or municipalities suffer and decrease in deployment share of agriculture. And then when we go to look at the employment share manufacturing, increase of about the same magnitude, but with different signs. And then I also find no effect on employment shares on services, which I interpret as a first finding on a significant effect of structural transformation away from agriculture and into the manufacturing sector in specific, as I mentioned, due to more exposed locations to the shock. And then I'll go on to look at some potential mechanisms using the agricultural census data. So I first look at log total farmland, which is basically the total farmland inside each municipality. And I find no effect, no statistically significant effect, which could be kind of puzzling at first, because after a commodity shock, we could expect that more land is allocated inside the municipality is allocated to agriculture. But here we have to think that two possible effects are going on. One at the extensive margin that I just mentioned, more land being allocated to agriculture, but there is also an intensive margin effect in which the land already being allocated to agriculture before the start of the commodity shock simply gets more productive, is used more productively by the farmers, and it appears to be the case. So it appears that there is not an extensive margin effect, but with some auxiliary results in the paper showed that the agricultural productivity or the land productivity inside the farms is indeed decreasing. So it appears to be an intensive margin effect. And then these other two mechanisms also help to understand this increase in the intensive margin. Then I look to the log machine intensity, which I define as the total number of harvesters, planters, and tractors inside farms divided by the total farmland. And I see an increase in this measure of machine intensity. And also, I observe an increase in the share of land that is planted with genetically engineered seeds. So overall, I interpret this as increase in the use of capital, in the farms, being related to substitution of labor by capital, and also by an increase in the productivity of land inside the farms. And then lastly,
these variables are coming from where?
All of the variables related to mechanisms are from the agricultural census from 2006.
So this is 26 to 2017.
Yeah. The difference between 2017 and 2006. Yeah. Okay, and then I go on to look at the other mechanism, which is land inequality. And here I take the two possible difference, which are called the short one is the difference between, as in the other mechanisms here, between 2006 and 2017. But I also took the long difference between 1995 and 2017, mainly because we know that land inequality as a particular form of wealth inequality is very persistent over time and changes very slowly. So it will be interesting to see how both of them change. But nevertheless, in both cases, I observe an increase and a statistically significant increase in both measures, pointing to increase in land inequality in the more exposed locations. And then again, I interpret this as being related to displacement, and also with some auxiliary results. In the paper, I show that the farmland inside each municipality, despite not being increasing, it's being allocated to more larger farm owners, and possibly smaller rural owners, smaller farmers are being displaced away. Their land is being bought, for example, by large landowners, and they are being the smaller ones are being displaced away from the agricultural sector, possibly into the manufacturing. Yeah.
So I don't know if that's what you did, but can you do like share of land owned by like the top 1% or top 10%, or share of land owned by the top 50%?
Yeah. So
to see like the.
I think I have. Yeah. So I think I have. So yeah, what I did was actually to measure the, so as I said, like the top 1% is around, if you take the whole country is around, the top 1% holds around land with around more than 1,000 hectares. And then when you look at this, we indeed see that both the log number of farms with more than 1,000 hectares and the log area of the farms with more than 1,000 hectares are increasing over time, also because of the commodity boom. So these are the auxiliary results that I mentioned that are kind of related to the land being more, that are being like allocated to, or the larger landowners are buying the smaller properties or land from the smaller rural owners or farmers, and then they are kind of being displaced away from agriculture in this sense. Okay, so let me go back just a little bit. Okay, so again, this is the second mechanism related to land inequality, and then I just do a couple of robustness checks that I'll not go into further detail here, but anyways, I check all possible sorts of alternative standard errors, including some recent proposed inference problems in shift share scenarios, for example, the paper by Rodrigo Adorno co-authors. I also do some different definitions for the commodity exposure measure. So I define, for example, dummies for above and below the median exposure, the top and bottom 10%, 25% of the exposure, as opposed to the continuous measure that I just showed you, and results again remain pretty much the same. I also add some additional controls to control for, again, some different types of heterogeneous initial characteristics, but results again remain pretty much stable. And then finally, I aggregate observations at a larger aggregation level, particularly at the micro-region level. And again, they remain pretty much stable. Okay, so then just to conclude, the results show a sizable allocation of labor from agriculture to manufacturing. And in this sense, it corroborates the findings of Paula Bustos and co-authors on labor-saving technology in Brazil, particularly for the introduction of genetically engineered soy seeds. But one interesting thing is that we have some more recent evidence on widespread agricultural productivity change. So, for example, this paper of Moscona, he looks at a cross-section of countries at the time of the Green Revolution. So he explores if these more exposed locations to the Green Revolution experienced an increase in the experience a structural transformation because of the Green Revolution. And what he finds that indeed these places that are more exposed actually slow down structural transformation by absorbing labor into agriculture. So again, we still have some kind of ambiguous evidence on the effects of increasing agricultural productivity or increase of the agricultural sector. It could depend on trade openness. It could also depend, for example, on labor-saving technology. And the idea here is that I present some further mechanisms regarding the importance of use of capital or capital intensity at the farms and rising concentration of land that could be working as a substitution of labor. The capital could be working as a substitution of labor, and also land inequality could be displacing the workers away from agriculture. And just a final comment, I like to stress like this key role of agricultural modernization, because again, if you think of the theoretical and empirical evidence that we have that I mentioned in the first slide, there's this interaction between trade openness and agricultural productivity. And if you assume that Brazil indeed starts, the municipalities of Brazil indeed starts, most of them start the period with an initial comparative advantage in agriculture, and also there are small open economies, we should be, at least in the theoretical work to have so far, we should be observing, because of the comparative advantage effect, and labor being absorbed into agriculture and slowing down structural transformation. But what I argue is that these key roles of agricultural modernization and land inequality could be overcoming this kind of natural comparative advantage effect of drawing labor into agriculture. So this effect could be sufficiently large to overcome this kind of mechanical or natural comparative advantage effect that we indeed observe in the literature. And that's all that I have for today.
So I have a question here. So like,
yeah.
I don't know if that's the direction you're aiming for, but like, I think this kind of relates to this debate on like small farms, large farms, and misallocation of land in agricultural productivity, because you kind of find this effect that the extensive margin doesn't change and the intensive margin changes, and you increase a lot. Like, I don't know if it's a productivity measure, but like you increase the production there. You have a demand shock, so I don't know. But is that something like you think you can contribute to in this debate of like, okay, yeah, in the Brazilian case, larger farms are more productive, and that's like try to relate that as an evidence to like this Restuccia, Rogerson, and like kind of like the Prisudri recent paper on that. I don't know, just thinking of.
Yeah, no, that's actually pretty interesting, because there is like this whole literature. There's not much literature about it, but there is like this recent Restuccia papers on kind of this micro level misallocation. And there is also, I think, Volrath's paper that shows that the cross section of countries, higher land inequality is associated with lower agricultural productivity. And in some of the Restuccia papers, he finds the opposite, and I'm also finding the opposite here. So yeah, because one thing that I really want to do still is to construct a model to kind of show all these mechanics in a more intuitive way and not only empirical. So yeah, I think I'll probably try to frame this better in this kind of new literature of the misallocation and so on, because I think it's kind of
because
interesting.
the extensive margin 0 is interesting. I don't know. I think for me.
Yeah. I also found it interesting at first, and I found that it's like there is also this effect on the literature, is like the Borderlog hypothesis, I think, which states that, for example, after the degree of evolution, this could have happened, like land is being more intensively used, and this could be like potential benefit effects on deforestation and so on. So it's also very interesting, I think.
And the second comment I have, like, so like in your regressions, you're running them at the municipality level, and they're not like kind of like weighted by population or anything. Like, so what I'm curious, like, how much is this driven by small municipalities versus large municipalities? Because kind of like the interpretation. So I have the interpretation of something that like affects the 2,000 smallest municipalities in Brazil versus the interpretation of something that affects the average municipality is pretty different, right? So like, you have 1991 census to like divide the sample by baseline characteristics. So I think that would be interesting. Or maybe just like weighting your regression by, I think it probably will mess things up by weighting your regression by number of individuals in each municipality might be interesting just to know what's going on. I don't know.
Yeah, no, that's actually a great comment. Yeah, I definitely have not taken it into this consideration. I'll definitely add to the to-do list. Yeah, it's very, yeah, I actually
and
really
it's fast,
don't know.
I think.
Yeah, it's pretty fast. I really don't know if it's being which actually the geographical distributions, which municipalities are I don't know if it's like very the distribution of the more exposed localities are very sparse at the geographic, or they are concentrated. So yeah, I think it's be very interesting to see. Thank you. I think, yeah, no, I think there was a question in the chat, but no. Okay, so I think if we do not have any further questions, we can end this section here. So thanks everyone for attending the section. Thank you again, Gabriel and Roberto, for the excellent presentations. And I hope to see you soon, pretty soon, not virtually anymore in the coming years. Okay, so.
Bye.
Bye everyone.
Thank you everyone.
Bye-bye.
Thank you.
Bye.